A hummingbird's heart beats 1,200 times every single minute. Right now, in your backyard, inside a creature the size of your thumb, your heart beats around 70 times per minute and you can feel it after climbing one flight of stairs. This tiny bird is running at 17 times that speed, continuously, while hovering in midair, wings blurring at 80 beats per second. And here is the part that should break your brain. The physics of that heart rate should be literally impossible. The forces involved should tear cardiac muscle apart. The heat generated should cook the bird from the inside. By every rule we understand about how biological systems work, that chest should explode. So why doesn't it? Let's start with the math, because the math is where reality gets genuinely strange. Your heart muscle needs to contract, release, refill with blood, and then contract again. That cycle has a minimum mechanical time limit. The muscle fiber has to physically relax before it can fire again. Engineers call this the refractory period. For human cardiac muscle, that period is roughly 300 milliseconds. That's why your heart maxes out around 200 beats per minute under extreme stress, and even that can cause fibrillation and death. A hummingbird's heart completes that same full cycle, contract, release, refill, in 50 milliseconds. That's 6 times faster than the theoretical limit for mammalian cardiac tissue. So either the physics is wrong, or a hummingbird is running on fundamentally different biological hardware. It's the second one. And what evolution built inside that tiny chest is one of the most sophisticated pieces of biological engineering on Earth. Hummingbird cardiac muscle fibers are structurally unlike anything in your chest. They are packed with mitochondria at a density that would make a biochemist cry. We're talking about nearly 40% of the total muscle cell volume being mitochondria, pure energy factories. In human heart muscle, that number is around 30%, and we already consider that remarkable. The hummingbird doesn't just have more fuel. It has a completely redesigned combustion engine. The proteins that drive muscle contraction, specifically myosin heavy chains, exist in a faster cycling isoform in hummingbirds. Think of it like this. Your muscles use a standard gear ratio. Hummingbirds evolved an entirely different transmission. The mechanical stroke is shorter, faster, and recovered almost instantly. It's not bending the rules of physics. It rewrote them at the molecular level. But here's where it gets even stranger. All that speed generates heat. Massive amounts of heat. At 1,200 beats per minute, a hummingbird's core body temperature should theoretically spike to lethal levels within seconds. Except it doesn't, because hummingbirds operate at a baseline temperature of around 41 degrees Celsius. That's already higher than yours. They are running hot by design, and their enzymes are calibrated to function optimally at temperatures that would denature your proteins and shut your cells down. They're not overheating. They built a body that thrives in conditions your body considers a medical emergency. If this is already blowing your mind, subscribe right now. We cover the science that textbooks buried in footnotes. The stuff that makes you question every assumption you had about how life works. Now here's the second layer. And this one hits differently. To fuel a heart beating 1,200 times per minute, a hummingbird needs an insane caloric throughput. They consume roughly half their body weight in sugar every single day. If you scaled that to a human, you'd need to eat around 75 kilograms of pure sugar daily just to stay alive. Your liver would fail in hours. Your kidneys would collapse. Your blood would turn to syrup. Hummingbirds evolved a liver that can switch between burning sugar and burning fat with a speed and efficiency that biomedical engineers are actively trying to understand and replicate. During the day, they're running on nectar, pure fructose, processed at a rate that would kill a human. At night, they drop into a state called torpor. Heart rate crashes from 1,200 beats per minute down to 50. Body temperature drops to near ambient. Metabolism falls by over 90%. They essentially become cold-blooded for 8 hours every night just to survive until morning. They are warm-blooded animals that temporarily become cold-blooded on a daily cycle. That is not supposed to be possible. Physiology textbooks say mammals regulate body temperature constantly. That's the whole point of being a mammal. Hummingbirds looked at that rule and ignored it entirely. And here's the implication that should genuinely excite you. Researchers studying hummingbird cardiac muscle and torpor mechanisms are now chasing applications in two critical fields. The first is cardiac medicine. Understanding how hummingbird myosin isoforms enable ultra-fast cycling without tissue damage could point toward treatments for human arrhythmias and heart failure. The second is organ preservation. Torpor physiology, slowing metabolism to near zero without cellular damage, is directly relevant to how we might one day transport donor organs for much longer periods, or even how we might approach human suspended animation for long-duration space travel. A 1-gram bird hovering over a flower is, right now, providing the blueprint for future human space exploration. That's not poetry. That's where the research funding is actually going. The hummingbird didn't break the laws of physics. It found solutions to physical constraints that we never imagined were negotiable. Every limit we assumed was hard: maximum heart rate, thermal tolerance, metabolic fuel switching. This animal treated as a design challenge and engineered around it over millions of years of evolution. That is the real lesson here. Not that hummingbirds are impressive. It's that our models of what's biologically possible are almost certainly still too conservative. Every time we think we've mapped the edge of what life can do, something the size of your thumb shows up and runs 17 times faster than our theories allow. If you want more science that rips up the rulebook, subscribe and hit the bell. Next video will make you question something else you thought was settled. I promise it's worth it.